In this tutorial, we're going to graph transformations by hand. So here is a function, g of x, and let's think about first of all what the parent function would be. I'm going to call it f of x, and it's just going to be a quadratic function. All right, so let's identify, do I have an a, h, b, k, are they given here? All right, so do I have an a value? Yeah, I do. It would be a -1 out front. Do I have h? No, nothing is added or subtracted to the x. Do I have b? Yes. I have a 0.2, which I, out of habit, just changed to fractions. So it's 1/5. And my k value would be 5. So what does this mean? It means, well, I have a reflection across the x. I have a horizontal. Now this is counterintuitive. It's not going to be a shrink. It's going to be a stretch by the reciprocal factor. Horizontal stretch by a factor of 5. 5/1. Which is why at the beginning, when I saw 0.2, I immediately made that be 1/5, so I can do the reciprocal easily in my head. And then I'm going to shift, it's a vertical shift up 5. Right? From this point, I take my parent function, okay? So I'm going to take my critical points of my parent function. This is how I do this without picking up a graphing calculator. Now, I certainly use a graphing calculator to check this if it's available to me. And I think my key points. So if I plugged in into this x squared, -2 would produce 4. -1 produces 1. 0, 0, 1, 1, 2, 4. And I'm going to apply these transformations now in my correct order. So what's happening? Well, I'm reflecting across the x. So this one here, and I'm shifting up 5, both happen to the y value. I got to do it in that order. So I got to multiply first because I'm reflecting first, and then I'm shifting up 5. So I'm going to take this value, times it by -1, and add 5. Times by -1, add 5, which is going to produce, let's see, this is going to be 1, 4, 5, 4, and 1. Now, to the x value, I have a horizontal stretch by a factor of 5. That means I'm multiplying each of my x's by 5. And that's going to produce -10, -5, 0, 5, and 10. So just to make it clear, this is my new x coordinate, and here's my new y coordinate. So I'm going to go over the coordinate plane and graph these. So when I plot these, I'm going to connect this to make my parabola. So I can definitely see it's been reflected across the x. It's then shifted and definitely horizontally stretched out compared to the parent function of a quadratic. So let's look at one that has the reciprocal function as its parent function. These are often ones that kids find to be tough. So your parent function here would be f of x equals 1/x. And then when I look at this original, so I have 15/x, just consider for a second that this is equivalent to 15 times 1/x plus 3, that these are really the same statement. And then it's probably helpful to look at it that way to consider a, h, b, and k. So yeah, now I have an a value. It's 15. And then what else do I have? A plus 3 at the end, so that's going to be k. I don't need to worry about the h or the b. So I'm going to have a vertical since these are both happening to the y values, they're going to be just as I think they should be. So vertical stretch by a factor of 15, and then I'm shifting up 3. So let's consider my parent function and some key points. I'll put f of x right here, so you know I'm talking about the parent function. So if I have negative, I'm going to pick some negative values, like -2, I plug that in, that gives me -1/2. Plug in -1, that gives me -1. Plug in 0, I have a vertical asymptote, okay, it does not exist. If I plug in 1, again I get 1, and I plug in 2, I get 1/2. Now let's transform. So I need to stretch by 15, so I'm multiplying, and then I'm going up 3. All right, so that's going to be -7.5 plus 3 is going to be -4.5. I'm going to go decimal format. It'll be easier on my brain to graph. -15 plus 3 is -12. And then 1 times 15 is 15 plus 3 is 18. And 1/2 times 15 is 7.5 plus 3 is 10.5. Okay, so here's my new ordered pairs. And one of the things I think about is, remember, just real fast, the parent function is like this. It goes like this, and it's a hyperbola 1, 1, like this, and I have a vertical asymptote at x equals 0. I also have a horizontal asymptote at y equals 0. So this horizontal asymptote is going to shift up 3 units with your function. So I'm going to erase this graph here because I only want the new function. All right, so it just will help me if I think about the fact that, oh, my horizontal asymptote is moving up 3. And since I don't have anything horizontally shifting, I know that I still have a vertical asymptote at x equals 0. So let's see if I can graph any of these points or if they're way off my coordinate plane. -2, -4.5. It's right here. -1, -12 is going to be down here somewhere. And I could use more points to make it even better, but that's going to give me a decent sketch. 118 is going to be way up there somewhere, and 210.5 that I can handle. This is all right, so it's going to be something like this. All right, so that's how you graph transformations without ever touching your graphing calculator.